this work is titled Predictive Modeling for Social Media Optimization, Predicting the Maximum Engagement Rate on Instagram. And the authors are Augustina, Addo, Nyinaku, Adjetey, Sandro, Kwame, Amofa, Prince Samuel, Kyeremateng, Prince Ofori, Hilary, Ackah-Arthur, and Kofi, Sarpong, Adu-Manu. So with me here is Sandro. He's part of the authors, but I'll be doing the presentation. And then when it comes to any form of question, Sandro will support me to answer the question. So I came with a backup. All right, let's go on. So I would like to find out, do we have anyone here who is not on any form of a social media platform? Okay, so what it means that all of us are on a social media platform. So if you are not on any social media platform, at least since many of us are academics or students, most likely will be on a LinkedIn. Okay, so if you are not on Facebook, Instagram, TikTok, and the rest, most likely will be on a LinkedIn. Or the one that is more pervasive is the one on our phone, which obviously is WhatsApp, and we may be in one or two groups. So this work actually talks about a predictive model on engagement rate on Instagram. When we post anything on social media, be it LinkedIn, Facebook, and the rest, we seek for some form of social validation. So we always go back to check the number of likes, the number of shares, the number of comments based on the post that we have posted. Now, imagine someone working as a marketer who is supposed to use social media to promote a particular brand. That kind of social validation or that kind of anxiety is actually more increased for someone who is a marketer. Because as a marketer, you want to make sure that whatever you have posted about that particular brand or that particular product, others are engaging in it. So in our work, we looked at how we can predict social media engagement. Typically, we are using the Instagram for it, and our focus was limited to the type of content that you post on Instagram. The limitation has to do with the text content, not much more about the pictures or the videos that you post. So we have it that somewhere in 2003, there was a little decline when it comes to social media, when it comes to Instagram engagement. But from our work, we realized that engagement is influenced by factors such as content, timing, hashtags, and relevance. For example, if there is a football match between Manchester United and Chelsea, and you want your post to be relevant, most likely you may want to use the hashtag Chelsea Man U, isn't it? Or you may want to use the hashtag Red Devils, or how do you call the other one? Blue Chelseas, or whatever it is. So realize that engagement on social media is actually influenced based on some of these attributes of a post. So in our study, we realized that the XG Boost provided a better performance when it comes to modeling the prediction of a social media post. So the approach that we use is more of a descriptive analytics to predict and also give a prescriptive strategies when it comes to social media posts. Now, the purpose of the study. The purpose was to develop a model to forecast the maximum engagement rate on Instagram posts, provide data-driven optimization strategy for content creators and marketers, offer actionable insights to address declining organic reach and rising advertising costs. We all know that when it comes to social media advertisement, it's one of the cheapest way of reaching many people. If you have some few dollars, you can always boost your post, and it can reach out to people that you not even think of reaching out to them. And we know that many of these algorithms behind this post are so powerful to reach out to more people than the normal or the traditional way of advertising, such as television and magazines. Now, for the methodology, we source our data from Hugging Faces with over 1 million public Instagram posts. But out of this 1 million Instagram posts between 2022 and 2024, we limit ourselves to about 100,000 of this kind of posts. And in order for us to ensure generalizability, we actually selected some posts based on some characteristics of those things. We make use of tools like Python 3.x, scikit-learning, pandas, and NumPy to create this. Now, in our development, we developed a web interface where we enter these attributes of posts. Mind you, we mentioned that things like the content, the description, the hashtags, and even the timing at which you are making your post can influence the engagement rate. So in our system, we develop a web interface where you put in this kind of content and this kind of attributes, and then based on these attributes, our model actually predicts the engagement that we are going to have. So upon experiments, we made use of several machine learning algorithms, but realized that the XGBoost supervised ML algorithm was the best as compared to the others. Now, for the feature engineering, we use capture temporal, textual, and account-based features. We use the TF IDF used for captions and bios of hashtags. We use the one-hot encoding for categorical variables. And then we derive features such as the likes to followers ratio for normalized engagement assessment. So if you look at this chart actually gives us the importance of the various features. So you can see it's actually blurry, but the very important features that was having more points was the category of the post. As I said in my example, if it's a football night and you post something about that particular football match, most likely you are going to have an engagement as compared to if it's a football match and you're posting about a football night and you're posting about politics. Your political post may not have that kind of engagement as compared to this. So the category of the post in terms of how it fits also increases the engagement. This is one of the things that I realized that feature is of a very high importance. Also, we have the number of posts. That is, if you are a usual, or if you are someone who actually posts a lot, most likely you may have an increase in engagement. And as well as if the post is the trending post at that point in time, most likely you are going to get more people posting. Also, the description of the post also increases it. So based on the various features of a particular post, we are able to come out with this graph. So our results and analysis. As I've already said, we realized that the XGBoost gave us an R-square of 0.916, which is about 91%. Random forest gave us 84%, and then the linear regression gave us 73%. Now, these are the feature engineering ranking. So in our modeling, we focus much more on this particular properties of a post. So for textual semantic, we actually rank textual semantic as the topmost feature when it comes to the analysis of a post in terms of the number of engagement. And this was influenced by the literature over there at the right side. We also look at the behavioral temporal patterns, the branding position, the feature type, the textual, then the contextual relevance, and then the audience targeting. So in audience targeting, language was very important. And mind you, our research was limited to the English language. We did not consider other languages that people would normally post in. So these are scatter plots showing the results and evaluation of likes and share. And from this chart, we can actually see that likes prediction and actual likes based on our model are more or less in line in terms of our predictive model as compared to what actually happens on the grounds or in real life. Okay, the same thing applies to our share prediction. And then we have a similar or slightly similar graph based on the safe predictions and then comments on posts. So realize that when you actually post, normally comments on posts are not as frequent as compared to likes and sharing of that particular post. Now let's look at the discussion and practical implication of this particular work. So we realize that we can use machine learning to effectively model complex engagement dynamics. Content relevance and timing outweigh follower count. In other words, the type of content and the time at which you are posting, it's so relevant as compared to the number of followers that you have. on any social media platform. Typically for Instagram, that's what our perspective was on. Findings align with the attention, economy, and cognitive engagement theories, and then predictive frameworks enable adaptive social media strategies. So this is what we found out, our practical implication. We realized that strategic timing, that is posting between 6 p.m. to 9 p.m., yielded 25% higher engagement. Now, this is in relationship with the relevance of the post as well, okay? Obviously, we may know that, okay, during this time, people are more relaxed to actually go through. Optimal use of hashtags, okay, also increase the visibility and also allow posts to be reached or to have far-reaching far-reaching audiences, okay? Then we also had a predictive dashboard that enabled data-driven posting and campaign planning. Now, ethical consideration. In doing of this work, because we are dealing with people's privacy, we have to actually consider some ethical things. So we actually apply data anonymization using the GDPR compliance. We also prevented profiling and manipulative targeting. And then we also advocate for transparency and fairness in the algorithmic recommendations. Now let's finish with our limitation. So our limitation on this work, with our data, we focus on both real and synthetic data to augment the data. So that's a limitation to this work. So even though our work is able to tell us that posting at this time with this particular relevance, with this particular kind of content can reach this amount of prediction or engagement, to predict the kind of engagement, we still have this limitation because we have to augment our data with some synthetic data. We also focus, as I've already mentioned, we also focus on textual and temporal characteristics, and this excluded important things like important visual elements like images, aesthetics, emotional expressions conveyed through visual content. We do not focus on anything that has to do with any form of graphics or picture. So this is also another limitation. Our platform was specifically on Instagram, so it's very difficult for us to generalize it and say that, okay, because it works like this on Instagram, it's going to work the same way with the other social media platform, because the other social media platform have their own ways of operating. So it's very difficult for us to conclude that this work can be generalized with the other social media platform. And the last limitation we have here is that we focus on the English language post, so we do not consider other languages. So for future research, we will be looking at multimodal integration, bias detection, and fairness auditing, dynamic model updating and concept drift adaptation, cross-platform analysis, such that we may want to look at how the same model can be applied on the other platform to see the effect of post on the other platform. And then we also want to look at enhanced interoperability and human-centric AI design. So in conclusion, the study looked at Instagram posting, and we model how we can predict the engagement rate on Instagram posting. Based on the various machine learning algorithms that we use, we realized that the SG boost gave us a better value when it comes to what works. We also identify the engagement drivers such as hashtags, trending topics, and content quality over followers. And the framework provides actionable, ethical, and scalable optimization insight. Thank you.